So we're in section 10.5.
Sorry to interrupt.
That was a lot of work. All right, Law of Cosines, section 10.5. If you remember back in first semester, we did some of those logic puzzles where one person's dog was a poodle, but it wasn't named something, and the other person's dog was this. Scheduling the classes for the math teachers is like that. This teacher teaches Algebra 2, but has to have first period off, but can't have this period. And it was hard. All right. Before we talk about the law of cosines, let's remember which kinds of triangles we said that we could use the law of sines for. So we said we could use the law of sines when we had a side angle side. Sorry, angle side angle. Backwards. Angle angle side. Or side side angle. And we said for side side angle that sometimes we had an ambiguous case. We didn't do much with the ambiguous case other than saying that there is such a thing. So these three kinds of triangles are the kinds of triangles that we use the law of sines for. Angle side angle, angle angle side, side side angle. The law of cosines lets us work with a couple of different kinds of triangles. So let's talk about which ones those are. So law of cosines, we'll draw our triangle, label it like we did before. This is A, B, and C. So we label our angles with capital letters, the sides opposite with small letters. And the law of cosines works for any triangle. So we're going to talk about any triangle ABC and our sides. We end up with three equations, like we did for the with the law of sines. Equations are a little longer than our equations that we had before. A squared equals b squared plus c squared. Before I write the rest of the equation, what does this kind of look like? Kind of looks like the Pythagorean theorem. The law of cosines is kind of an extension of the Pythagorean theorem. So a squared equals b squared plus c squared minus 2bc cosine a. B squared equals a squared plus b squared minus 2ab. Sorry, I wrote this down wrong. A squared plus c squared minus 2ac cosine b. There we go. And our third equation, c squared equals a squared plus b squared minus 2ab cosine c. So a couple of things about our equations. If I have a squared on this left side of the equation, I have cosine a on the right side of the equation. So here I have a squared, here I have cosine a. Here I have b squared, cosine b, c squared, cosine c. So one side is on one side of the equation, and the angle that corresponds to that side is on the other side of the equation. All the other sides on this side of the equation are b's and c's. So the only place that side A shows up here is on this side. The rest is b's and c's. Here I have side B. Here I have sides A and C. Here I have side C, and I have sides A and B. So So that will help you remember, make sure that you write your equation the right way. And we said that this part of the equation, this first part, looks kind of like the Pythagorean theorem. Well, the cosine of 90 degrees, if one of our angles is 90 degrees, cosine of 90 degrees is 0. So this whole part, 0 times anything is 0, that whole part would go away. So if we have a 90-degree angle, the law of cosines turns into the Pythagorean theorem. The law of cosines really is just an extension of the Pythagorean theorem. And I said these are 3 equations. It's really just one equation. It's always the same. Just depends on how we label our sides. If I switch the sides and the angles around, then these would all just be the same equation. It's just the same way, 3 ways of writing one equation. All right. So questions on what the law of cosines, what our equations are. What we're going to use the law of cosines for is solving triangles, just like we did with the law of sines. Law of cosines works for 2 different kinds of triangles, different than the kinds of triangles we use for law of sines. We use law of cosines for a side angle side triangle. So 2 sides, an angle between. Guys, let's put the electronics away, please. And the second is when we have a side 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 triangle. So these are the 2 kinds of triangles that we use with the law of cosines. Side angle side, side side side. So what I want to do today is just go through a couple of examples of using the law of cosines to find missing parts of triangles. A lot of times with the law of cosines, the problem will ask you to solve the triangle. So you're finding all the missing parts. When you use the law of cosines, because these equations are kind of long, we can use the law of cosines once, and then we usually finish our problem with the law of sines. So if we're asked to find more than one missing part of the triangle, usually we'll use the law of cosines. If we have one of these kinds of triangles, we'll use the law of cosines to find one part and then finish the problem with the law of sines, because the law of sines is way easier to use than the law of cosines. So let's look at a couple of examples. So here's our triangle. And we'll call this triangle ABC. C equals 8, A, you don't know, and B equals 14. And for this one, we just have to find one thing. We want to find A. Find side A. And I forgot one thing, otherwise we wouldn't be able to do it. That's 50 degrees. So our triangle is a side angle side triangle. So we have a side angle side. That tells us we can use law of cosines. Alright, so we're finding side A. So I'm going to write the equation, the law of cosines equation that has side A on one side. So I have A squared equals B squared plus C squared minus 2BC cosine A. Well, I'm trying to find a squared, so I know that has to go there. And I know angle A, so I know that I have to have cosine 50 degrees on this side of the equation. And I'm just going to start putting my numbers in. B is 14, so I have 14 squared plus 8 squared minus 2 times, and I need to move my cosine 50 over, 2 times 14 times 8 times the cosine of 50 degrees. Now I'm going to write these steps out. I'm going to write a lot of steps out to make sure that, to point out where people usually make mistakes. You don't necessarily have to write as many steps as I write up here, but I just want to make sure that everybody's on the same page in terms of how we do these problems. So I'm going to say a squared, 14 squared is 196, plus 64, minus 2 times 14 times 8 is 224, times the cosine of 50 degrees. Now right here is where a lot of people will make a mistake. They'll say, oh, I have 64 minus 224, and they'll subtract those two numbers. The 224 and the cosine of 50 degrees are multiplying each other. So remember, PEMDAS tells you to do multiplication first. You can't subtract this 224 from these numbers. This is multiplying the cosine of 50 degrees. So you can't subtract here. So that's one place that a lot of people will make a mistake, is they'll subtract 224 from whatever's over here. This is multiplying, so you can't subtract it. All right, so a squared equals 196 plus 64 is 260. Minus 224 times the cosine of 50 is 143.984. So I multiplied 224 by the cosine of 50 to get this number. Now I can subtract. A squared equals 116.016. Notice I kept 3 decimal places. Here's where another place where a lot of students make mistakes. This gives us a squared. So to find a, I have to take the square root. A equals the square root of 116.016. So a equals about 10.8. And now if the problem asks us to find more parts of this triangle, now I have an angle and a side opposite. So now I could use the law of sines to finish. And we'll do an example of that in the next example. All right, so be careful here. Realize that these two numbers are multiplying each other. You can't subtract this number until you multiply it by the cosine of 50 degrees. And then remember that when we're finding a side, the law of cosines gives us a squared. So we have to finish by taking the square root to find our side. One other place where students will make mistakes is if my angle is bigger than 90 degrees, the cosine of the angle turns out to be negative. So I have a negative times a negative. So then we end up with a positive number here. So if our cosine is negative, remember that this is a negative sign out front, and a negative times a negative gives us a positive. So that's those 3 places are where most people make mistakes with the law of cosines. Forgetting to multiply these two, forgetting the square root, and when we get a negative number here, remembering that a negative times a negative, I end up with a negative times a negative. All right, questions on that example? All right, let's do one more example. We'll do a side, side, side this time. So here's our triangle. And this time we'll call our angle P, Q, and R. They don't always have to be ABC. And side Q is 1.25. Side R is 3. And side P is 2.5. And we want to find all angles. So we have a side-side-side triangle. That tells us we use law of cosines. And if I tried to start this problem with the law of sines, and I tried to set up fractions with the angle on the sides opposite, I would end up with two missing angles. So I wouldn't be able to do anything with the law of sines. So we're going to find all of our angles. Now before we even start the problem, we know that side R is the biggest side. So angle R is going to have to be the biggest angle. Side Q is the smallest side. So angle Q has to be the smallest angle. And angle P is going to be somewhere in between. So if we come up with an answer that's different than that, we know we've made a mistake somehow. All right, so let's set up our law of cosines, and we're going to find the biggest angle first. When you're using the law of cosines, you should try to find the biggest angle first. So we're going to find the measure of angle R. So I know that I'm looking for a measure of angle R. The law of cosines is going to have the cosine of angle R in it. So I know on this side, on the right side of my equation, I'm going to have cosine R. On the left side of my equation, I'm going to have R squared. So I'm going to write my equation here. R squared equals P squared plus Q squared minus 2PQ, and I'll move my cosine R over. So now I'm ready to plug in numbers. So I have 3 squared equals P squared is 2.5 squared plus Q squared 1.25 squared minus 2 times 2.5 times 1.25 times the cosine of R. So there's all my numbers. And I'm trying to find angle R. So we'll end up solving for cosine of R. So I get 9 equals 2.5 squared is 6.25 plus 1.25 squared is 1.5625 minus 2 times 2.5 times 1.25 is 6.25. So here's where a lot of students will make a mistake. They'll say, oh look, I have 6.25 minus 6.25. That's 0. We can't subtract yet because this 6.25 is multiplying the cosine of angle R. So I'm going to add these two together. 9 equals, these two added together is 7.8125 minus 6.25 cosine R. I'm solving for cosine R. I'm trying to get this part with angle R by itself. So I'll subtract 7.8125 from both sides. And when I subtract 7.8125 from 9, I get 1.1875, and that equals negative 6.25 times the cosine of angle R. We're almost done with this part now. I want the cosine of angle R by itself, so I'm going to divide by negative 6.25. And I get, turn this around, cosine angle R equals negative 0.19. I have the cosine of the angle. I'm trying to find the angle. What do I have to use? Inverse. I'm going to use the inverse. So R equals the inverse cosine of negative 0.19. So finally I get R equals 101 degrees. So I'm going to put that in my triangle. So I found angle R. The problem asks us to find all the angles. Now I could set up the law of cosines again for one of the other angles. But you can see the law of cosines, not difficult, but it's a lot of arithmetic. And there are a lot of steps. So we're going to finish with the law of sines because now I have angle R and side R. So I can set up the fractions for the law of sines. So I'm going to do that here. So we're going to use the law of sines to finish. And I'll do that in blue. So here's one pair that we have. Yeah, Preston.
How did you get 101?
Inverse cosine of negative 0.19. Make sure you put a negative in there. Okay, got it? All right. So we're going to use law of sines to finish. I'm going to set up my first fraction with this angle and this side. So I'm going to say sine of 101 degrees over 3 equals, and we'll find angle, let's find angle Q. So I'm going to say sine of angle Q over side Q, 1.25. Multiply both sides. I want to get sine Q by itself, multiply by 1.25. So I get sine Q equals 1.25 times the sine of 101 divided by 3. So I want to show you, I'll go through on my calculator, show you how I put this in from here. There's my calculator. So I'm going to put in 1.25 times sine of 101, and I want to close this parentheses. If I don't close that parentheses, I'm not going to get the right answer. And I divide by 3. And I get 0.4090. Like my nice blue calculator here. How about this one? All right, so we get 0.4090. So we'll go back to our problem. So sine of Q equals 0.4090. Notice I kept 4 decimal places. I have the sine of the angle. I want the angle. What do I have to do? Use the inverse. So Q equals the inverse sine of 0.4090. Plug that in my calculator and I get angle Q equals 24 degrees after I round. So I'll put that in my triangle. Now do I have to use law of sines again to find angle P?
No.
No? What can we do? Add these two together, subtract from 180. All three triangles in my triangle add to 180. So now I can just add these two together and subtract from 180. So 101 plus 24 is 125. So to find the last angle, 180 minus 125 is 55. And I get my last angle. And notice the big side is opposite the big angle. The small side is opposite the small angle. The medium side is opposite the medium angle. So that tells us, hopefully, that we did everything correctly. And all of our angles add to 180. If you end up finding three angles and they don't add to 180, that definitely means you made a mistake. All right, questions on using the law of cosines? All right.